All chapter 6, lesson 8, one of the toughest lessons of this chapter, fractions with different algebraic denominators, ladies and gents. Let's go ahead and pause whatever the assignment is. If you need to check assignment for page 169, pause the video, come on back when you're ready. And of course, you know I love questions, so if you have any questions, bring them to class. So, adding, subtracting fractions with like denominators, check. Adding, subtracting fractions with like numeric denominators, check. So now it's time for different algebraic. Take a look. Basically what we did, if I change this to a 7, 8 sevenths minus 3 sevenths, then we get to different numeric denominators. Now it's time for different algebraic denominators, and of course that can get cranked up a notch for Algebra 1. Go ahead and pause, whatever the date, whatever the assignment number, pause, write this down. Come on back when you're ready. So, ladies and gents, I would argue that this top type of problem you're going to be pretty good with. For instance, let me draw a picture here. Let me go ahead. I'm going to draw 1/3 or cut up the rectangle into thirds. I could also cut up the rectangle into fifths, vertically speaking, of course. And naturally, what you can surmise is that 15 would be an excellent common denominator. Now, you won't be surprised to say that 1/3 is the same amount as 5/15. Same amount of pizza, different size slice, but same amount. 2/5 would be the same amount as 6/15. If you don't believe me, 5 times 3 is 15, so be fair to that numerator. And lest you be concerned, yes, ladies and gents, you can cut something up, you can go underwater, you can have a negative portion. In fact, some people would even write that with the negative out in front. I would, of course, accept either because they mean the same thing, just different ways of representing that quantity. Okay, Mr. Callan, I get it, but now we take a look. What if there are a variable or variables in the denominator? In this case, we still have cut things up into thirds for the first fraction. But the second fraction, we don't actually know how much it's cut up. So we'll call that an unknown p. What you can figure out, though, if we just focus for a moment on this, what you can figure out is that if you cut something up into 3 rows and p columns, the total number of pieces would be 3 times p. We just don't exactly know how much that is exactly. All right, so let's do the same thing that we did up above and ask ourselves, how do we get from this denominator to this denominator? Well, perhaps not surprising, you're going to see that we're going to have to multiply 3 times p to get 3p. And anything we do to the denominator, we have to be fair to the numerator. Now, if you'll forgive me for being repetitive, we keep talking about this. The fact that this amount of pizza is the same amount as this, those are equivalent fractions. They're just cut up now into a better, more friendly, we should say, denominator. All right, now let's look at the other way around. Let me get rid of that. And if I want to get from p to 3p, you won't be surprised to see that we'll have to multiply denominator and numerator by 3. Therefore, that's going to make 6. All right, now we don't know exactly what that denominator is, but we do know it's cut up into 3 pieces, both of them, and we're going to subtract MP pieces minus 6 pieces. Now I pause for a second and ask firstly, can these quantities be combined? Are those like terms? The answer is no. One has variables, the other is a constant term with no variables. So those are not like terms that can be combined. The second question will be, can we reduce something into all terms? Now, I almost said 3, but we don't know what MP is, so we can't just divide everything by 3. I almost said P, but this term does not have a P. Therefore, our final answer in simplest form will be MP minus 6 all over 3P. Now look at how those problems are similar. Look at how they're different. Obviously, the top has all numbers. The bottom has numbers and variables. But I would argue there's a whole lot more similarities than differences. We still need a common denominator. You still need to set up equivalent fractions. You still need to figure out what to multiply both denominator and numerator by. You still need to be fair. Anything you do to a denominator, do to a numerator. You still need to check at the end if it can reduce to simplest form. There's a lot of similarities here. If that was a little tricky for you, you may go ahead and pause, go back, rewatch it. For the rest of us, we're going to continue on. R and R squared. Now, if you need to come off to the side, expand out both of these into their algebraic factorizations. Circle what is in common and writing it once and only once. Also, any remaining factor. And perhaps some of you already spotted it, that our common denominator here will be R squared. Now, that's great because we already have R squared here. Therefore, the second fraction does not need to change. But the first fraction will. So we ask ourselves, R times what equals R squared? Now here I keep seeing some people say R times 2. But folks, R times 2 is just 2 envelopes of money. On the other hand, R times R is what will make R squared. So we'll need to multiply both denominator and numerator by 5R. Now that we have a common denominator, we can write R squared there, 5R plus 2. Can those be combined? The answer is no. Can anything be reduced? The answer is no. So our final answer will be 5R plus 2 over R squared. Now let's continue on. But as we do these problems, ask yourself, how are they similar? How are they different? Notice that X and Y have nothing in common. So you write each factor once, and therefore XY will be our common denominator. All right, bit by bit, how do we get X into XY? We're going to multiply both denominator and numerator by Y, giving us a new numerator of 7Y. Let's take a look at the other one. To get Y to XY, we naturally will have to multiply by X, leaving us with 5X's. Now that we have our common denominator, we're not exactly sure what size slice that is, but we do know it's X times Y size. 7Y, take away 5X. Can that be reduced to 2? No. This is Y's, this is X's. Those are not common, those are not like terms. Can anything reduce? Now this one almost fooled me because I saw that 2 of them have an X, but this term did not. And one could argue the same about Y's. 2 terms have Y's, 1 does not. In fact, there is no amount other than dividing by 1, but that doesn't really reduce anything. So our final answer there will be 7Y take away 5X all over XY. And for one more, ladies and gents, again, think about as I'm talking, how are these problems similar? How are they different? Here we have 2x, which I guess is already in its algebraic factorization, but interestingly enough, they share the x. So we're going to write 2 times 3 times x for a common denominator of 6x's. Now be careful with this. If we are going to figure out how to get from 2x to 6x, we already have all the x's we need. We really just need to multiply by another 3. 3 times 2x is 6x. Let's be fair to the numerator to have a new numerator of 9. Onward we go. How do we get from 3x to 6x? In this case, we'll have to multiply only by 2. We don't need any additional x's to multiply by, and therefore that new numerator will be 2y. Let's go ahead and put these together. 9 cannot combine. Nothing reduces. So our final answer will be 9 minus 2y over 6x. And yes, I suppose you could rewrite that, but I'm not going to push you too hard on that. We're going to focus more on writing and adding, subtracting algebraic fractions, and less on the algebraic way of writing the variable terms in front of the constant terms. So don't sweat that. All right, if you need, pause and rewind, watch these 4 examples. Rewind if you need to for that one example as well. Some of you are ready to jump into homework. If you are, go ahead and stop the video and continue on. If you're feeling a little fuzzy on this, I'll do a couple extra problems just to help you out. Looking at A, B, and A. In fact, if you went off to the side and expanded those out, you'll notice they already share an A. You only have to write A once times B, which further means that the first fraction does not need to change. The second fraction will. Not surprisingly, to get to AB, we'll have to multiply B, and you may write the 1 if you wish, but you don't have to. Final answer here, when we add up the numerators, keeping our common denominator, nothing will reduce into both of those. 2 plus B all over AB. Heading off over to number 31, you'll notice how this one's a little different because we have both numbers and variables. So we take a look at this, we add an x, we got a 5, well, why not multiply those together to get a common denominator of 5x. Now, 5 times x, y times x, I'm going to choose to rewrite mine alphabetically. It's not wrong if you write yx, it's just not the best way to write it. We always want to write multiple variables alphabetically. Back to the first fraction, we'd have to multiply that by 5, so let's be fair to the numerator. Multiply both of those and we get 10. So now once we have our common denominator, we have 10 slices, we take away, well, some unknown amount. Almost tried to reduce it by 5, but there's no 5 in that first term. So that, ladies and gents, is as good as it gets. There's 2 extra little bonus examples for what I think could be one of the toughest assignments, as well as one of the toughest just concepts to understand and skills to learn. So go ahead, whatever the date, whatever the assignment number, continue on with page 171. Please be sure to bring some questions to me if you got any. Take care, do well, and let's grow, folks. See you.